Hello, hello. Welcome back. So last time we left off, we had created gravity, masters of our world and all. And we've created a system of connecting things together. So in this case, the game with the spawners, with us as a player, and us as a player dying, which then tells the game to respawn us. Right, I forgot. We gotta fall a really long distance. But yeah, anyways, we die, respawn, come back. So that's, it's a good basis to start building out a game. We have health, but no enemies, and no way to take damage except by falling to our death. So that's what I want to do in this hour, is start off by building our first enemy and giving it a behavior, steering behaviors for NPCs and such. Now, I don't know if it's something we'll finish in an hour, but I guess we'll see. And before we do that, none of that is meaningful if we don't have a little bit of feedback in the form of some UI. We want to kind of show our HP at the very least, just so when we take damage, we know we've taken damage, and when we've died, we know why. So yeah, I'll start the timer here, and we can start building out UI and then enemies. So it always takes me a second because of the way the timer is set up. I really should have just used a proper timer. I'm doing this in the most hacky way possible, but I'd rather be showing you how I make a game than writing a custom timer. There we go. Cool. Right. UI. So game engines typically come with a UI component, something that allows you to make a UI. It isn't always amazing, unfortunately. Unity's is meh. They know that, so they're rewriting it, but it seems like it's going to take a while. Unreal's as well, not amazing. I'd say the only one that has a really amazing one is Godot, but that's because initially, they took a decision of just writing the engine using the engine. So everything that's the editor is included standard, which is amazing. Which is why I see a lot of tools made in Godot and not the other engines. But anyways, it's okay. We're not trying to do anything insane. What we're going to do is add a UI canvas. And actually, we don't even need to add a canvas directly. What we can do is just add some text. And Text Mesh Pro, which prompts you to add stuff. Examples. No, we don't need any examples. But the reason why we use Text Mesh Pro instead of regular text, text, is that Text Mesh, if I can learn how to speak, is designed using SDF, which is distance fields, signed distance fields, which means that text is going to appear sharp no matter the condition of, how much you zoom in or whatever. It's kind of like the difference between Adobe Illustrator and Photoshop and vector art and raster art. Yeah, so it's it's super nice, to be honest. Okay, so what we're gonna do is switch this over to 2D, show the whole canvas. And we're going to give ourselves a couple of rules. So since the screen can change sizes based on who's playing and with what, we're going to scale it. And we're going to take a reference resolution of... I guess 1920 by 1080. And what we're going to do is match width or height. Yep. No. Yes. We're gonna match width or height. We're gonna match the normally heights, right? So let's try heights and see how it goes. And that's our canvas. So within our canvas, we want to have a panel, and you know, you can just move things around and position it, but that means whenever the screen size changes, it's just gonna change where everything is. So it's better to kind of go through and actually position things properly. One sec. I'm really enjoying my coffee, guys, sorry. But actually, like, give things anchors and pivots and such, so that as the screen size changes, things don't like go crazy. So health, we're gonna place our health up here, or our panel up here, well, or down here. Let's do down here. So what we want to do is we want to anchor stuff using this as the kind of origin. So bottom left, and the panel itself currently pivots at the middle, meaning that's its reference point. We actually want to move that to 0, 0, which is down here as well. And that gives us kind of a very consistent, you know, place to start. And what we can do is give ourselves a width. So, you know, we've got a reference, so it scales, meaning we're always going to be working in a width of 1920, sorry. So we can take a width of 400, I think, and a height of, let's say, 200. And then we position it. Let's just give it a bit of space. I'll keep the panel look for the moment. Typically that is something you want to replace with custom art. But, you know, we're building this in 6 hours. It's not meant to be amazing. So we can then add actually a second panel. We can just create an empty, I guess. Create an empty. We're gonna call it health section, I guess. And health section, we're gonna position that based on a pivot of, sorry, an anchor up here, and we can actually just manually adjust this because we know this panel is not going to change neither in size nor in location. Like, the panel will move, but everything within the panel is going to stay as is. So we can just, you know what, I think the panel is a bit too high at 200, maybe 150, 100, 130. Yeah, that looks nice. And you see the health section never moved because we've anchored it properly, whereas this one is all over the place. We never anchored it. So yeah, position-wise, that's fine. We want to put this as a child of this as well. Give ourselves kind of a fixed amount of space, maybe that big, and the size of the font is just too big at the moment. So we can probably move that down to 24. And then we'll set it so that it's centered on the horizontal. And yeah, left aligned is fine. We're going to say health. And then position the stuff properly. Why is that doing this? Health section is this. Has a bit of weirdness going on. 150. Oh, sorry, that's fine. That's height. So what we want to do is actually match these. So say if this was 64 and 365, just to use round numbers, we can make this 64 and 365. So say we want to take 365 divided by 3, so a third, and then just kind of round it. So that is an internal kind of thing. Am I missing something? Why do we have an margins 0, 0, 0? Okay, so that was margins. Okay, makes sense. Height 130, height 54, not 64. So I'll just do 54 here, and we can position this. Actually, a better way to do that is to anchor it to center left, and then just give yourself a 0 position. And actually move your pivot on the x-axis to 0, 0. Yeah, then you have to reset this, sorry. Yeah, and that means now your origin is here, and it will always start on this side. Even if you grow the width, you need more width, it will always grow in this way. Cool, so that's going to be health text right here, health text. And we're going to add a second piece of UI here, and it's gonna be a slider. So that looks nothing like a health bar, but we are going to fix that. So again, we're gonna anchor this to the right side with a pivot of mid on the Y and end on the X. So 1 is end. It's always, you know, whatever the width actually is. And we know we've got a width of 365 minus 100. What was it? 120. So 365 minus 120. 365 minus 120 gives us exact pixel perfect positioning. And does height affect things? It does. And we do want it to affect things. So we want height to be 54. Now, obviously, there are ways to automatically scale these things, but we don't need to bother because we are just doing this for like once. We're not creating dynamic bars or anything. Yeah, so source image, we can probably delete this, and handle, we can delete the entire handle. Can we? Don't know if we can. We can definitely delete the handle. And then fill area, fill, delete the sprite as well. And what we can do now is actually set a background color. So let's say dark red, right? Even darker. Yep, dark red. And then your fill area is now red, red. You must have a graphic target to use it. That's, what is that? Target graphic. Whatever, let's see how this works. Okay, so obviously we've got a bit of a difference between the two. And that is because background has 0, 0 here, and fill actually has a size. So if we set it to 0, I think I think. That will... Oops. That will not work. Okay, let's try that again. 10. So let's just undo a bunch of these and bring back the handle. Yeah, that must have a graphic target, so we're gonna target the handle. Just give it a quick refresh. Yeah, okay. Now that we've reset, let's see if we can fix this. So this changes the handle stuff. Okay. Rework this properly. Let's keep all this and then actually just disable this, which hopefully doesn't break the slider. Guess it still does it? Oh yeah. Wrong thing. Okay. See how that works. Okay, that works. So we want to get rid of that kind of minimum maximum thing we've got going on there, where a minimum has a tiny bit of line and then maximum has a bit of gap. And we want to do that by going into the background, reworking kind of our stuff here. Anchors on the Y. So you see how you've got a bit of margin? That's because the anchors are not at max. So if we just change that to kind of 0 and 1, and then set our kind of margin type thing, then fill area fill. So fill area also has a bit of gap there. So let's take that again to 0, 0, 1, and again to 0, 0, 0, 0. That fills the whole thing, and then the actual fill has a width of 10. Let's see if we move that, what happens. That becomes -5 on the right and -5 on the left. Let's turn that, take that to 0. So the anchors are driven automatically, which is the right thing. So if we delete this, actually, that should fix the problem, I think. So now when we go to value 0, we can't see it. Let's reset the colors. So we'll go with a dark red and a fill of bright red. Nice. Okay. We probably want to do whole numbers. So in this case, just for testing, we'll say we have 100 max health, and that's smooth. If we had 10, then 0, 1, 2, 3. Perfect. Cool. That looks nice. Whew. Okay, that was harder than I thought it would be. Cool. We have a kind of UI now. Now, canvas, UI, event system, game controller. We should probably now have a UI controller. And a UI controller would, we've got our game controller, it's got game. Then we've got scriptable objects, we've got the game scriptable object. Let's duplicate that. Say UI controller, UI, let's just call it UI. And we can remove all the kind of stuff we've got going on there. And UI is going to be much simpler. It's basically just going to be a passer of events, unless we need to initialize stuff. Could probably add an initialize function. Initialize method, and an initialize, we'll just leave it for now. Well, yeah, no, we'll leave it for now. Because we're gonna do stuff soon. So in UI, we want to kind of know where things are, right? So what we can do is UI. Text Mesh Pro, TM Pro. Using TM Pro. I don't know if we can actually do it in this way, but it doesn't hurt to try. Actually, I'm sure we can't do it this way, so let's take this off. So what I'm trying to do is actually find a way to link UI to actual UI elements so we can find them. But thinking of it, I think that's actually a bad idea. Let's instead just add UI here. And just need it to reload. We can again go to data where we've got game. We're going to create a new Hey, things went on a really weird crashing tangent for a second there. But I figured it out really quickly. It took probably 5 minutes, so I reset the time a bit. I cheat a bit, but it's okay. So what happened was, for some reason, this was set to mono behavior, which makes game and UI inherit from mono behavior, which is like completely the wrong thing that we want to do. We don't want to do that. We want it to inherit from scriptable objects, which might be a mistake I did last time, but didn't realize it. But anywho, back here again, we can now go to data and add a UI scriptable object, which then we can go into game controller and add that here, and save the prefab. So what we want to do now is, when we do anything that changes something in terms of the UI, we want to push that event into the UI scriptable object, basically. So when it comes to health, right? So health is something that links to game. Let's also link it to UI, because now we want it to affect UI as well. And if we go layer prefab, we can connect that to the UI. And so what we do here is, where we've sent an event that says death when you die, every time your health changes, we also want to send an event. So health has changed. After we've reset everything to the correct numbers, we want to send an event to UI. Let's say player health, and we're going to change. So a bit of a hint, actually, something that will make things a bit easier. Send event now takes an array of objects, which means that if you remember previously where we had used it in death, we sent a new object array that just had this in it. There's actually, I think, a better way to format this, which is to put in the params keyword here. And what that will do is allow you to just do this. Yep, so this will automatically turn it into an array and then push that through. So again, here we can do the same and say we're affecting. Actually, let's not even do player health. Let's just do health, and then we're going to send this in here. And on the UI elements, we're going to check if it's player health. Just to kind of show a even more flexible implementation of it. So on the panel itself, health section, we can actually now call this health bar because we didn't need to kind of split things. We can add a new script and call that health bar UI. And probably move it to the correct folder as well, so we can stay organized. So it's a behavior under UI behaviors, and we can grab health bar UI, throw it under UI behaviors. Then open that up. Cool. UI behaviors. So we want to do stuff to do with the Unity engine.ui namespace. That's because we want to change stuff to do the slider. We can just add a slider element, slider reference, and when we start, actually, it'll autofill. Private void start. When this element starts, when this game object starts, we can basically, we'll need a UI reference as well. We want to add a listener to UI with the event name health. And we wanted to update health with an object array parameter. Update health. So what this does is now we're linking this method to listen to health events on UI. So whenever a health event is called, we're gonna grab the parameters here. So we know that there's only one parameter. So if parameters.length is not equal to 1, we're gonna return so we don't crash. And then if not parameters 0 is health, we're as well gonna return. So now we have our parameter as health available to us. And then we're gonna check if not try get component on health. So player movement should don't even need that. Out player movement. Going to return. So in this case, we're checking if this is a player's health, and if not, we're just going to exit as well. Finally, it's the player's health, it is a health, and it's not an incorrect number of parameters. We're going to update the UI. So health slider dot max value first. Max value is going to be the maximum of 1, and so the reason why I'm doing this is I'll tell you now, but so maximum of 1 and health dot max health, and then health slider dot value is equal to the maximum of health dot max health and the minimum of max health and health dot health. In fact, we want to actually clamp things rather than use maximum, so we're going to clamp it between. So max health is between. Well, actually, we're not going to clamp max health because there's no maximum max health, but the actual health value we're going to clamp between 0 and max health. So Unity has this thing where if you set incorrect values or kind of weird values to health slider, it'll just break until it's reset. So rather than just set the values directly, we are sanitizing them first. So max health can never be less than 1. It'll take the maximum of 1 and max health, and then the value that's assigned will be clamped, so it'll never be less than 0 and never more than max health. And those are kind of sane values. So even if you kind of come in and initialize at a weird, negative 75 max health and positive 10 million health, for whatever reason, it happens, who knows, it won't break the UI. Yeah, so that now should work. But there is a caveat. Is there a caveat? No, the health doesn't listen to anything. It's only sending events, so we're good. Since the player gets destroyed, if there's something on the player listening for events, we need to destroy that listener on its destruction. So let's first of all see here. We've got an error and the health bar didn't work, and the reason for that is because we never set these. So we're going to set the UI and we're going to set the health slider. Still doesn't work. Why doesn't it work? Let's see. Value 0. Why is value 0? It's because our health never changed, and therefore it never emitted an event. So first of all, we should also probably emit this on a heal as well. And then on start, let's emit that. Probably okay. Probably okay. Yes, because it's gonna spawn. Is it okay? We'll see. Should be fine, yeah. There should be at least a frames delay. Yep, there we go. So I was worried about... Nice. Well, Welcome to Unity. I actually hit the X, I X'd the window by mistake because it locked my cursor, but I couldn't see it when I clicked. I X'd it. Welcome to Unity Dev. What needs to happen is I need to give it a click, and then now we can't like exit out. So what I was worried about is a race condition between the health event being sent and the UI actually getting hooked up. So if the event gets sent before the UI is hooked up, it wouldn't update the health. But that didn't happen, and the reason why that didn't happen is because we're spawning, and the spawner actually takes a second, like not a second, but point something of a second, 0.001 maybe. And the first frame the UI gets, hooked up, and then the second frame maybe, or the third frame we spawn. And that should be reliable enough. So let's try us dying. We die, the health is gone, and then health is back. Cool, so the health bar works. We don't have a way to take regular damage, so we can't actually check or see it working perfectly, but at least we know it works. Something I've noticed is the health, the panel not being dark enough. So let's actually just take it to black and a little bit more opacity. Should look better. All right, another thing, we could probably rename this to UI canvas so that it's in line with everything else, just my OCD. So we now have a working health system. Let's work on getting an enemy in. So Blender, just because it's free, open source, and I know how to use it. We don't need a camera or a light. I'm going to keep the cube because this being a programmer's game, we're going to make the enemy a cube. Sue me. We'll just do 45 degrees and then 45 degrees. It doesn't look right. Yeah, so actually let's just hack this. We will join these two vertices, same here. So for the visual style, I'm just defaulting to my programmers. Let's make it look retro, because that doesn't take time, and it's fun for me. So we are gonna make the enemy look like this. Then just add a second cube here, or you know what, I'll just dupe this, bring it here, shrink it. Look at how beautiful this enemy is. And if we really wanted to go overboard, let's make this red, and then cube 1. Green, purple. Oh, what about it red here and kind of a silverish here? Yeah, I like that. Call this silver. We'll call this material red. And that will allow us to override them easily. Oops, M&M stuff. Where's our project? It's called here. Fake game in 3 hours. It's not, we're done with 3 hours and we're not done, so that even that's fake. Cool. assets, we'll add a art folder and a models folder, and then entity models. And in there, we're gonna add a, we're gonna say floater. That's the name of our enemy. Now, one thing to note, the scale of this is massive. It's good to kind of scale things correctly. So that's a 2x2 if we have that. This is how high we are. So we probably want to take it down to about here. And then we can set this centered. Nice. Very usable. We'll export it as an FBX, just because. Blender can't convert blend to FBX. Story of my life. Update Blender, break Unity. But it's okay. That's why we did an FBX export. FBX export art. There we go, art. And what we want to do is actually create a prefab of this again. So one thing you can do is take the whole UI thing, drop that into its own scene and load that in dynamically. But for now, we're just going to leave this massive UI thing floating here. And not care too much. A floater. Grab that floater. Does it look okay? It does. I'm a fan. And just to be kind of more organized and scalable, you want to add a floater object that's an empty at 0, 0, 0, and then put the model in there, reset where it is, and then kind of set its position kind of like that. And then this whole thing can be prefabbed. Again, into entities, we have a floater entity, then we can delete this. If we open up the prefab, we get kind of an isolated environment where we can do cool stuff with it. So first thing we want to do is add a collider. Since this is not a humanoid, we probably can do a spherical collider. Bring it up a bit so that it's in line. And it's good as well to kind of make it slightly smaller. Like that. Yep. So a good trick for this type of enemy is to actually put it in a different layer, into an enemy layer. And same with the player. So let's actually do 7 as enemies and 6 as player. And then that gives us a lot of fine-tuned control over all the different kind of physics and detection and all that stuff. So we're not filtering things after we have collisions. Instead, we are, not doing that. We get kind of pre-delivered lists that are already ready to go. Yeah, so enemies, change everything to enemies, and we can as well add a second sphere collider, make it a trigger. Kind of take the same center, and then make this a trigger, and we can grow this a bit. And that can be our hit zone. Right? And typically if you wanted to have these, is this okay? I don't think this is okay. What we can do is actually add an empty, call it hit zone, and we will just actually put this component over here. So instead of it being on floater, it's now here on hit zone. And what that allows us to do is, among other things, scale. Can we scale? I don't even know, to be honest. The advantage of doing videos during the day is that I have energy. The disadvantage is doorbells and stuff. So yeah, I had to grab the doorbell really quick. You can't scale these. I didn't know that, but never tried actually. So, however, that is weird because we in M&M we do scale stuff, but it might be spherical colliders don't work when you scale them, since they're uniform. So instead, maybe instead of a spherical collider, we can use a different type of collider. A box collider, why not? Move the hit zone up. And we could probably rotate this so that it's, yep, so that it's more in line. 45 degrees. And then shrink it on the Z. But we'll make it big so that things get hit. We wanna give this a controller, character controller. All right. That I guess that is something. Character controller is also a collider. So we could skip the character controller and just directly affect the transform, but that means we're gonna have to kind of work our own physics in. Instead, we could just turn this into a sphere. That way. Slightly hacky, but I like it. We'll make it bigger as well. And that means you can delete this one. Nice. So floater, this is gonna now need a script. So where we have our player controller, our player movement controller, we could probably piggyback on the same one, duplicate it, and then we'll bring it to entity behaviors and just call it, rename it to NPC movement. And obviously a lot of this stuff goes out the window. So we still need the delta. We can let's see. Do we have pitch? We don't. No pitch. It's just gonna be yaw. So we can take off pitch and the pitch object and pitch speed. These can now be not constants, but actually variables. We'll call it maximum speed, turn speed, and gravity Well, gravity actually can remain as a constant, but we are going to float. Nice. Let's take that off. We'll make these public so we can influence them, and we're gonna add one more that says public boolean affected by gravity. Default it to true. Just to be organized, we're gonna move the const back to the top. And yeah. So we're gonna do one thing additional, which is yaw always starts at 0, but we're gonna set the character controller. Don't need this one. We're gonna grab the character controller and then immediately reset the yaw. I'm just gonna grab the transform actually, and rotation. So we wanna grab the Euler angles and then the Euler angle. That is our yaw. So we're gonna grab that. Yeah, cool. And we're still gonna maintain that kind of going, using the yaw as yaw facing, and recompute things every frame, just so we don't have drift and stuff. But we're gonna start at the actual facing. We should probably do this for the player controller as well, player movement. And the reason for that is that sometimes maybe the spawner is facing a different direction. You don't want to spawn in and then immediately be facing the wrong direction. Then we are going to just change this up a little bit. Vertical velocity equals to 0 if affected by gravity. We are going to grab we're going to put in this. So actually do the gravity thing. Ah, this is a float. Okay. And then we are going to you know what, I deleted the thing where we do the yaw rotation. So let's just grab that again. So what I want to do here is I want to make this public so that we can influence the yaw from outside this class. And we also want to influence the velocity from outside this class. Or velocity. Yeah, velocity from outside this class. See, that's always the question. Do you want to like take that out and do that, or do we want to just give ourselves a destination and make this class kind of figure out how we're going to get there? And that question is really, do we want to add another component that decides how we get there, and that can be changed from entity to entity, or do we want to just have one? So I'm going to just make a decision and say we're just going to have one. No need to make this more complicated. And that means that this can go back to being a private. And that gives us a thing where we want to know, so we know destination now. We have a destination. We want to set that destination as wherever we are. To start once we spawn. And then we're just gonna like, so have we're gonna have the gravity affect us, and then immediately if destination minus position, current position, transform.position dot magnitude is less than 0.2, I guess. Sorry, is greater than 0.2. We want to move. So how are we going to move? First of all, we want to get our yaw in line with, you know, heading to that destination. So do we want to set it or do we want to turn? Probably turn. And 420 is very fast. We can probably take it down to 180 to start with. So we're going to turn at that speed. How do we do that? We are going to change our yaw. We need a target yaw. And we get a target yaw by quaternion. So what? There is a formula where we use arctan to get this. It's something I look up every time because you do it once and then you copy paste it throughout the entire project. And I'm wondering, I don't think Unity has a built-in function to do that. I think we can get a Euler vector. I'm just going to Google this real quick. From two vectors atan 2. Okay, so target yaw is atan 2, so math atan 2 the tangents of the two planar axes. So we wanna get a difference in x, or is it so we want to get a cross product at some point. I don't remember how to do this, to be honest. It's been a while. It has been a while. And x and y. So cross product of the forward and the right is, oh man, this is gonna give me headaches. But you know what I can do? I could just pull and just copy paste what I have for M&M, can't I? Because I've already done all these calculations. This is kind of something that you would put into your kind of repertoire of things that you use, and then you don't want to be sitting there reworking out trigonometry every time, and rather just have something that you can let's move that off screen so you don't see my other secrets. Face. Okay, so cool. So first of all, we're gonna make it have a direction vector, which is we're gonna normalize a vector from our position, our destination minus our position. That gives us a direction vector, and then we are gonna take an ATAN2 of the directions x, the direction z. We're gonna multiply that by math f dot rad to degrees, so convert it to degrees, and that is target yaw. Whew. Not so bad. Then we want to move our yaw to our target yaw. And how do we do that? If you just kind of get your target yaw and you get your yaw and you want to make him the same by just adding or subtracting, you run into a problem where what if let's say you're at 359 degrees and the target yaw is 0, right? Can't see myself. Yeah, so 365, target is 0. Instead of just making that tiny adjustment, you're actually going to go all the way around and come back. So you want to detect which direction to go, even if it loops. And that isn't the simplest thing to do, but I mean, just taking a couple of logical steps, you could easily do it. I mean, the most important thing is that your target yaw is going to be between a 0 and a 360, 359 point something. Similarly, that your yaw is going to be in that range as well. So first we're going to figure out what is yaw delta without taking a kind of over the 360 line jump. So we're going to do a target yaw minus yaw, and then we're going to do a yaw delta 2. Let's say yaw delta 1, yaw delta 2. Yaw delta 2 is going to be target yaw minus 360 minus yaw. Is that the case? So say you are at 350. So I mean we can actually theory craft this out. Target yaw is 1. Your yaw is 359. So yaw delta 1 is, I mean, why not switch them so it's a bit easier to comprehend? Is 358. Right, so it's positive 358. In this case, target yaw is -1. Yaw is 1. Yaw delta is -2. Right? So it's -1 minus 1 is -2. So then we want to take yaw delta is target is I'm going to take an absolute value of yaw delta 1 is less than math f dot absolute value of yaw delta 2, then we're going to take yaw delta 1. Otherwise, we're going to take yaw delta 2. Now, this is a shorthand, which you could write out as an if, else, etc. So this could be, so this is if this is true, take this, then this. So let me just comment this out and write it out longhand. Because if you don't know this notation, it's super useful. I like it. A lot of people don't because it's sometimes harder to read, but I think it's super useful because it does a few things. For example, you don't need to declare and then set this to 0 beforehand. Or, you know, maybe don't need to set it to anything, but you'd have to kind of declare this first. And then yaw delta is equal to yaw delta 1 else autocomplete yaw delta is equal to yaw delta 2. So this is this basically. So let's keep this for now. Now that we know we've picked a delta that's a shorter way, we can check, we can get a turn velocity is equal to, or turn delta, yaw delta, turn by, so the yaw delta, basically yaw delta times delta time. And also times turn speed. Is that right? That is not right. What we want to see is actually get a, we want to get a turn speed. Let's see, turn speed. Delta turn. Let's do a delta turn. And that is turn speed times delta, and if your delta is negative, less than 0, we want to multiply delta turn by -1. So that means if delta turn is positive, we want to take a positive turn ratio, turn speed, turn command, and if it is negative, we want to take a -1. Additionally, we don't want to overshoot. So if delta turn is equal to, is greater than yaw delta, well, this is problematic because what if they're negative? So let's say if delta turn is positive, if delta turn is greater than yaw delta, we want to set delta turn to yaw delta. Similarly, if it is negative, then if delta turn is less than yaw delta, we want to set delta turn to yaw delta. And there's one more case where we're actually facing the exact right direction. And in that case, I think never happens because float will always have some small variation, but which means you can keep kind of making micro adjustments. That's not going to be noticeable to the player. But here, so if target yaw is equal to yaw, it's not equal to yaw, then we're going to do all these actions, because otherwise you can just skip trying to turn. Correct. Correct. And yeah, so now we have a delta turn. We're gonna take yaw and we're gonna add delta turn to it. Cool. Next. I mean, I'm aware we've run out of time. I was aware of it a while ago, but I decided to ignore it for a sec. What we will do now is just finish off the this portion of the movement code, and then we will do steering next hour. So velocity is equal to, so here we've got our yaw rotation, and then we want to delay this stuff. Yep, so our next video is going to be about, now we know which direction we're facing. Do we move forward? And if yes, how much? And then apply that to the velocity and move. Just thinking. Even though we've got a not affected by gravity, I think we'll just do everything affected by gravity for now, and then figure that out after. Maybe even have a pitch and a pitch object in there. But more to do with aiming, I think. Right, okay. That's it for today. I think we achieved a bit less than we thought, but you know, it's been a it's been a good, you know, kind of good amount of technical achievements in this hour. Catch you next time.